Good day! In this lesson, you will learn how to solve the greatest common factor of the numbers, or what we call GCF of the numbers, using factor tree method. What is greatest common factor? It is defined as the largest number that is a factor of all the given numbers. In this lesson, we will solve GCF using factor tree. So if you are not familiar with prime factorization, please study the lesson on prime factorization on my channel. What is the GCF of 42 and 84? We will solve this using factor tree. So let's factor 42. Since 42 ends with 2, so this is divisible by 2. 42 is 2 times 21. 2 is prime, but 21 is not, so let's factor 21. 21 is divisible by 3, means we can divide 21 by 3. So if we divide 21 by 3, we will get 7. So we can factor this as 3 times 7. So 3 is prime and 7 is prime. Now let's go to 84. 84 ends with 4, so that can also be divisible by 2. So 2 times 42 is 84. So this one is prime. 42 is not. This is also divisible by 2. So we can have 2 times 21. 2 times 21 is 42. So this is prime. We have 21 divisible by 3. So we can factor 21 as 3 times 7. So this is now prime and this 7 is prime. So let's list down the prime factors. For 42, we have 2 times 3 times 7. So this is 2, 3, and 7. For 84, we have 2 times 2 times 3 times 7. So we have 2, 2, 3, and 7. Now we can identify the common factors between two numbers. We have 2, we have 3, and we have 7. Then let's multiply the common factors. So we have 2 times 3 times 7. So we got it from these common factors. So we multiply 2 times 3, that is 6, times 7. So that is 42. Our GCF is 42 when we multiply 2 times 3 is 6 times 7 is 42. Now let's find out what is the GCF of 36 and 48. 36 is divisible by 3, so we can factor this by 3. So 36 can be 3 times 12. So 3 is prime, so we can factor 12. 12 is 2 times 6. So this one, 2 is prime. 6 is not prime, so we factor 6 to 2 times 3. Now 2 and 3 are prime. Now let's go to 48. 48 is also divisible by 3. So that is 3 times 16. 3 is prime, 16 is not. So let's factor 16, which is 4 times 4. 4 is not prime, so we can still factor 4 to 2 times 2. And this another 4 2 times 2. Now, all these numbers are prime. Let's list down the factors. For 36, we have 2 pieces of 2, 2 times 2. Then we have 2 pieces of 3 times 3 times 3. Then we have for 48, we have 4 pieces of 2, 2 times 2 times 2 times 2. Then we have 3 times 3. Now, let's identify the common factors. So we have 2 here, and we have 3 here. Then, let's multiply the common factors. This, you have 2, this is 2, and another pair of 2, then another pair of 3. So, we multiply 2 times 2 is 4, times 3 is 12. So, our GCF is 12. Now, let's solve the GCF of 60 and 90. Both numbers ends with 0, so means this is divisible by 10. So let's split this or factor this using 10. 60 is 6 times 10. Then your 6 can still be factored by 2 times 3. Now we have prime numbers here, 2 and 3. Your 10 can be factored to 2 times 5. Okay, so 2 times 5 is 10. So we have prime 2 and 5. So let's go to 90. That is 9 times 10. 9 is not prime, so we can factor it. If we factor it by 3 times 3, that is 9. So this 3 is prime, and this one is prime. Now let's go to 10. We can factor 10 as 2 times 5. So all the numbers now are prime. Let's list down the prime factors of 60. We have 2 pieces of 2, 2 times 2. We have 3 and 5, so times 3 times 5. Next, for the 90, we have 1 piece of 2. Then we have 2 pieces of 3, 3 times 3. Then we have 5 times 5. Now, let's look at the common factors. So we have 2 here, we have 3, and we have 5. So let's multiply the common factor. The common factor is 2, and we have 3, and we have 5. So that is 2 times 3 is 6 times 5 is 30. So our GCF for this is 30. Let's factor 3 numbers, 15, 25, and 60. The number 15 ends with 5, so we can factor it using 5. So 15 is 3 times 5. So this is now prime, and this is prime. For our 25, you can use 5. That is 5 times 5. Both numbers are prime. For our 60, we can use first 6 times 10. Then our 6, you can factor it by 2 times 3. This is now prime. Then for our 10, you can factor it as 2 times 5. So these are prime now. Let's list down the prime factors. For 15, you have 3 times 5. For 25, you have 5 times 5. For 60, you have 2 pieces of 2 here and here. Then times 3. Then times 5. Let's find out what are the common factors. Okay, we only have one common factor for the 3 numbers. So our GCF is 5. To learn more on prime factorization, you can check out the lessons on prime factorization on my channel. I hope you can now solve the GCF of 2 or more numbers using factor tree. Lesson for LCM will be uploaded next. Thank you for watching. Please don't forget to share and subscribe.